Well, I'm here with Brendan Lang, who represents the electrical side of the Climate Safe Rooms. So Brendan is responsible for looking after everything electrical, starting with the electrical assessment.
That's right. G'day, Morris.
G'day, Brendan, and welcome.
Thank you. So I'm an electrician, and my business, Get Off Gas, motivated to help people electrify their homes to save money and create a healthier space and a safer space, which is what the Climate Safe Rooms is all about. And as you touched on, the first step of that process is to do our electrical assessment. And there's many parts of that. One of the key components is that we've got an electrician there coming into the home and analysing the wiring within the house, both the physical and the electrical capacity and the condition of the wiring throughout the house to make sure that it's ready to have the upgrades required for the Climate Safe Room.
So you actually put eyes on some of the wiring?
Yeah, that's right. So we'll take the switchboard escutcheon or the cover off and have a look at the state of the cabling in there. You can get some really good indications as to what's been done in the house and how old the wiring is once you take that cover off. And then you can start to delve a little deeper by hopping into the access panel, into the roof cavity or maybe a wall cavity, taking off a couple of switches or power points and starting to understand how old that wiring is throughout the house.
Right. And typically what have you found during this program?
Generally, most of the wiring has been upgraded at some point in time. It's roughly a 30% ratio of homes that haven't had some sort of extensive renovation or upgrade works done that has then triggered some of that wiring to be upgraded in the recent past. Cabling that's up to 25, 30 years old is still more than adequate for use. It's when you start to get that really old black rubber cabling that's starting to degrade and break down that we need to look at rewiring a few different components of the electrical infrastructure.
Right. And how have you found the capacity of the switchboards generally?
Always on the light side, and that's inherent because if you look around the home, 30, 40 years ago, you might have had one or two power points and a lamp in the corner here or there, and now everyone's got air fryers and hair dryers and straighteners and laptop chargers coming out the wazoo, so a lot more demand on the power infrastructure within the home. And so the original switchboard is only set up for that, one light and one power point per room. So we're going to be asking a lot more of that infrastructure. The home's appliances are going from being fueled by things like gas and even coal heaters to now being fueled by an electric source. So it's no wonder that we need to increase that capacity of the switchboard, both physically and sometimes electrically as well. So that means having a look at the mains cable, which is actually coming in from the street, and making sure that that's got enough capacity to undertake these changes.
Right. Right, so there's quite a lot to it.
There sure is, yeah. It takes quite a bit of experience to sort of keep an eye out for these little quirks, and you pick up the indication, and then that you pull on the little string and you go down that rabbit hole and get all of the information that you need to make sure that you're well aware, because unfortunately I'm not born with x-ray vision, so I can't just look inside all of the walls about where the wiring's going. But if you see if you have an indication perhaps that something's been done by a home handyman or an extension lead's been used, then you can kind of get an idea of where you need to focus your attention perhaps in the home.
Yep. So sometimes there is like rewiring that has to happen.
Yeah, there is. Just by nature of the homes being older, and maybe those renovations haven't occurred over the years, and this is the first time that someone's really gone under the hood and started to change some of this key electrical infrastructure.
But I assume that most of the time it's there's some capacity. You can just add the reverse cycle air conditioning.
Yeah, that's right. Typically the lowest supply capacity that you're going to get to a home is around about that 32 amps. And that means you can have all of your general purpose power points, you can have your oven, and quite easily add a small air conditioner onto that. A bedroom air conditioner may only use 3 to 4 amps whilst it's running, so quite low power draw compared to the air conditioners of days gone by.
Yep.
They're really quite efficient now.
Yeah. terrific.
Yeah.
And they're, I think, almost always more efficient heaters than they are coolers.
Absolutely, yeah, they're extremely efficient for heating, and they, when you compare them to a resistive electric tower heater like the ones you might see in the aisles of Bunnings, the label on the air conditioner and the tower heater are actually not speaking the same language. So you might refer to an air conditioner as being 2.5 kilowatts, and that's in a bedroom, and then you look at the tower heater from Bunnings and it also says 2.5 kilowatts.
Right.
The air conditioner is actually referring to the heat loading, not the electrical loading. That reverse cycle air conditioner will really, in reality, be using about 500 watts to run. So it's about 4 or 5 times as efficient as that tower heater. So it's not like for like when you're comparing those two wattage numbers. So it's just something to be aware of.
Brendan, if part of the climate safe room process is also getting off gas, what other things have to happen?
Yeah, it's an important consideration, even if it is going to be a staged approach for removing those gas appliances and replacing them with electric, that the switchboard capacity has enough physical size for the additional circuit breakers to come into play. Each one of those little slots on your electrical switchboard is called a pole. So if you go and count your switchboard at home, you might have 8, 10, 11, maybe 24 poles if you're lucky. You want to make sure that you've got enough for each of your new appliances to have their own pole for its own new circuit, because each air conditioner, your heat pump hot water system, perhaps your induction cooktop, they'll all require their own circuit to go into the switchboard. So that's a really key consideration. That's the physical side. The other side is the electrical capacity. So making sure that consumer mains cable that comes in from the street has got an adequate supply to then feed those future appliances, and understanding what that limitation is, which is referred to as your maximum demand for those consumer mains, so that you know that when you get to, appliance X down the line, this is when a switchboard and mains upgrade might be triggered.
Right.
And have a really good understanding of
And so of those appliances, would it be, I'm guessing, that the induction cooktop is probably going to have the highest demand?
They do have quite a high demand. Contrary to popular belief, they're actually the most efficient cooktop that you can get, even compared to the ceramic electric. The ceramic electric will use the same amount of power as an induction when it's running. However, there'll be a lot more losses because the heating element is running the whole time. With induction, the electricity will only flow when the pot is actually placed on the top. And as soon as you take it off, the electricity will stop. So it's inherently much more efficient and much safer as well, because you don't have that burning element underneath. You'll see on your induction cooktop the overall power rating, and it might say something like 28 or 32 amps. That's the cumulative power consumption of all of those burners running at the same time.
Right.
That's right. So
it's really unlikely, isn't
totally unlikely. I mean, I don't cook anything like that. I'll normally have the water boiling, and maybe I'm cooking some fish or some protein here and on a medium to high heat, and that's about it. Each one of those burners on the induction cooktop might use 6 to 7 amps whilst it's running on that high setting. So if you're running that back on, halfway along, say 5 or 4 or 5, then you're really using a fraction of what the total capacity of that cooktop is. So they're quite efficient and not hugely power hungry when you're just using it day to day. In some circumstances where the supply is constrained, there's models of induction cooktops from the manufacturers that are for low power draw. So if it's very difficult to get a cable to a particular location, like in a brick apartment building, you can get these low power draw induction cooktops that can plug into an existing power point. They still sit in your bench, so they look like your Schmidt glass cooktop, but they only use a smaller amount of electricity, which does have some limitations on how many you can run at a really high level. But you're still going to get a great cooking experience with induction. The next step back from that is to just use the plug-in induction cooktop.
Yes, just a single element. I shouldn't say element.
That's
single
right.
inductor.
That's right. The single burner there, and that's a really good way to get started with induction cooking, because you can often borrow them from the library, from the council, or IKEA or those sort of places.
And tell me, in the case of a home, if the cable from the street doesn't supply enough power, is that a big deal?
It can be. You need to ensure you've got enough electrical supply there, otherwise you'll have issues with tripping your main switch. You don't particularly want to have that as a persistent problem. So you want to ensure that you're covered with that capacity on the supply side before you start loading up the demand side of the equation with all of your appliances on top. And there's quite a bit of a process to that, and a good electrician can guide you through that process as to the application to the DNSP or the local network service provider, and get an appointment booked in for them to come out with their truck and sling a new line overhead. And that will often trigger extra little steps like installing a new meter enclosure which has got a hinge on it, or running a new main earth to the garden bed, and making sure that the whole installation has come up to the modern day standards.
All right. We've seen why every climate safe room begins with understanding the home, how it holds heat, where it leaks energy, and whether it's safe and ready for the upgrades ahead. The thermal and electrical assessments give us a costed blueprint. They're what makes this more than guesswork. They make it precise, targeted, and safe for comfort, safety, and lower energy bills for the people who need it most.